All right, so let's get into the area of a trapezoid. So once again, if I go too fast on these videos for you to take notes, please pause it, rewind it once you take your notes so you can watch the slide or whatever you need to do to be successful in doing this particular math. This lesson, 8.3, is going to put together lesson 8.1 and 8.2. So when we look at what we're asked to do here is be able to understand and find the area of a trapezoid. Now, trapezoids are, we are told, are quadrilaterals that have one pair of parallel sides. And what that means is if you look at this particular trapezoid example I put up, the top and bottom, they are parallel. They never intersect. They continue to go the same distance across from each other forever and ever if they were written as lines. Now, trapezoids can be drawn in different ways. We can have tall ones, skinny ones, we can have fat ones, we can have one side is going to be straight while the other one is leaning. But when I look at this particular trapezoid and I divide it into its individual shapes, then I can see that I have two triangles and a square or a rectangle. So when they talk about decomposing the trapezoid, they're saying, well, look at it and break it up into its smaller pieces and then do that math. Well, that math becomes a lot of steps that, if you need to do it that way, I'm fine with you doing it that way. But I would rather you just learn the formula for the area of a trapezoid and be able to apply it each and every time. If not, then you have to find the area of two different triangles and the area of the square or rectangle that makes up the trapezoid in the center, and then add that all together. So when am given examples such as this trapezoid is drawn what we would consider upside down. But I just have to look at the different parts and the different pieces. Notice at the top they give us basically one triangle and then a trapezoid, or they divide it into two different triangles and the rectangle. And instead of doing that, let's just look at it as the trapezoid itself. Now, they give us two different measurements up there on that top. So understand those two measurements would just simply need to be added together so you know the distance all the way across the longest base. So the formula that we look at is using the A or the B when it comes to bases. So whichever one you want to call, it doesn't really matter, but you have a base A and a base B or a base 1 and a base 2. That means that we're going to find the length of the top and the bottom, the two sides that are parallel to one another. We're going to divide that by 2 and then multiply that by the height. So when I look at what that formula is telling me, it is to find the top and the bottom measurements that are parallel and add those together. So I already have two things that I have to add together in order to use it mathematically. Looking at that very top line, you have 10 plus 2. Well, that's going to give you the 12. So I need to use the measurements of 12 and 7, the parallel lines, which are going to be my top base and my bottom base, and add those together. Once I do that, then I simply divide it by 2. Then I multiply it by the height, and the height, once again, has to be shown as a right angle, has to be a perpendicular line with a right angle in it in order for it to be a height. That's going to give me my area. So I go through the math. I do anything that's going to be separated first and then follow through with multiplication division. And I have 12 plus 7 on top. It's like being separated inside of parentheses. And 12 plus 7 is 19. So I have to divide those two, then multiply it by the height in order to find the area. Well, 19 divided by 2, I know that 2 goes into 19 9 times because that's 18, and I have one left over. So I can do decimals or I can do fractions. I prefer to do decimals so I don't have to make it into a mixed number. So I add my 0 and bring it down, and then 2 will go into 10 5 times. That is 10, so I don't have a remainder. So what I end up with is now I still have my multiply by 5, but I'm going to take my 9.5 or 9 and 5 tenths. 9 and 5 tenths times 5. Well, when I stack those, I get 5 times 5 is 25. And then 9 times 5 is 45 plus 2 is 47. Once again, multiplying decimals, I have to count my decimal spaces. There's 1, so if there's 1 in my math problem, I move it once from the right to left in my answer. That tells me that the area is 47.5 or 47 and 5/10, but I need my label. So when I see that I have inches, once again, since it's area, I'm always going to square it. So if I just learn this formula, even though it's new and might seem a little complicated, it's just doing basic math step by step by step. Once again, as I showed you on Monday, in the back of your planner are these formulas as well as throughout your book. All right, so when I look at the idea of what a trapezoid is, just keep in mind that we're talking about using that top and that bottom, that A and that B base, those are the sides that have to be parallel. To me, doing it this way, it's much easier than having to find the area of each of the triangles and then the area of the rectangle and then adding it all together, which is how they're showing you to do it in this first problem. But notice you should still, if you had all those together, get the same answer. All right, so let's look at this one. So I see that this one doesn't have two slanted sides. It only has one slanted side, but I still just need to use the parallel sides as my bases. So the top and the bottom, the 10 and the 6.1, those are going to be my A and B. Those are going to be my base 1 and base 2. And then I have my height, which is indicated by that straight perpendicular side of 9.7. When I plug them into my math formula, then I have 6.1 plus 10. I'm going to divide that by 2. Then I multiply it by the height, which is 9.7. So when I add my numerators, 6.1 plus 10 is 16.1 divided by 2, and then I would then multiply it by the height. So now I have to do the division. 16.1 divided by 2, well, 2 goes into 16 8 times, and that gives me 16. And then I have a decimal that I need to bring up, and I bring down my 1. However, 2 won't go into 1, but since it's holding a place value, I have to ask how many times will 2 go into 1, and that answer is 0. Then I add a 0 and bring it down. And then 2 goes into 10, 5 times. That gives me 10 as 0 remainder, so I know that I end up with keeping the height of 9.7, and I'm going to multiply that by 8.05. Multiplying multiple digits. Once again, it's a good review for us to continue to do because we're going to have to be able to do this in order to move on into 7th grade and to do well on our standardized test. So we're going to start with the 7 and multiply with it. 7 times 5 is 35. Put down my 5, carry my addition of 3. 7 times 0 is 0 plus 3. And then 7 times 8 is 56. I go to my second number. That's what I underline. I circle what it has behind it. So my second number tells me to bring down 1 0. And then I multiply with the 9. 9 times 5 is 45. Put down my 5, carry my 4. 9 times 0 is 0 again, plus 4 is 4. And then 9 times 8 is 72. I add those together, and I get 5, 8, 4, and 6 is 10, carry the 1, and then 5, 2, and 1 is 8, and 7. Now I have to count my decimal positions, because since I multiplied with decimals, and I have 3 in my math problem. Therefore, I have to move my decimal 3 times from the right to the left in order to put it into my answer. So I have 78.085, or 78 and 85 thousandths. When I look at my label, I can see that my label is units in this particular problem, so I simply put units squared as my label for my area. Is that making sense? I hope so. If you got a little confused, then what I would do is once you have the notes written down, just simply rewind this problem and listen to me as I'm explaining it, going through it, and I'm pretty sure that you'll be able to get it. All right, so when I look at this particular trapezoid, it seems like it's upside down, but it really doesn't matter how they draw my trapezoid. I just have to focus in on where my parallel lines are. Once again, parallel lines mean that they simply will never cross. They'll never intersect. So I know I have to use the 4 and the 2. So if you have to do that, I would like you to do this problem. Check it. The formula is there on the screen for you. come back and see how you did. All right, so hopefully you have an answer. Let's see if you set it up correctly. So we have our 4 and our 2 we're going to add together, and we know we're going to divide by 2. And then we have to multiply it by the height. My right angle, my perpendicular line, is telling me the height is 3. That one should be pretty easy. So 4 plus 2 is 6 divided by 2 times the 3. And therefore 6 divided by 2 is 3. And I keep the multiplication of 3 for the height. So hopefully you got that you have 9. But hopefully you also included your label of square centimeters. So 9 square centimeters is what you should have gotten. If you didn't and you don't know why, please ask, and then I'll see if I can figure out where your mistake was and help you out so you do understand it as we go forward. Okay, now using this real life scenario, we're going to still use the same formula. The area of a triangle is found by adding the base A and base B, and then dividing that by 2 and multiplying it by the height, which is once again indicated by a right angle. So when I look at this particular setup in this real life scenario, I can add the base A and base B, which is 2.5 and 4.8. I'll divide that by 2 and then multiply it by locating the right angle tells me that I'm multiplying by 4 for the height. Well, 2 plus 5, or 2.5 plus 4.8. Remember, when we add decimals, we have to line up our decimals first, bring down our decimal, and then simply add. 8 plus 5 is 13, and then 4 plus 2 plus that 1 is going to be 7. So what we end up with is 7.3 divided by 2 times the height of 4. So now I have to do my division. 7.3 divided by 2. Once again, the decimal on the inside tells me to raise my decimal first. So then 2 goes into 7 3 times, which gives me 6 and a remainder of 1. I bring down my 3 and 2 goes into 13, 12, or 6 times, which is 12. Because 2 times 6 is 12, then I have a remainder of 1. Have my 0, bring it down, and 2 goes into 10, 5 even times. So now I end up in my formula as 3.65 times 4, and I do the multiplication. So as I stack them, I multiply with the 4. 4 times 5 is 20, carry my 2. 4 times 6 is 24, plus 2 is 26, carry my 2. And then 4 times 3 is 12 plus 2, gives me 14. Multiplying decimals tells me I have to count my decimal spaces, so I have 2, and therefore I move my decimal from right to left 2 times. That gives me 14.60, but remember when we have our decimals and we're writing them as an answer, the only time I'm going to have a 0 in that last position is if it's the 100th position because I'm dealing with money. In this situation I'm not, I'm dealing with square meters, should be square meters, ignore the word units as my answer. So 14.6 square meters. Let's go through this particular example before I let you do one of the practice ones on your own. So we have a trapezoid and we have our bases. They are the parallel sides, therefore they are straight across from each other. We have the height of 16.5. So I'm going to plug them into my formula. I have my base A plus my base B. So I have 4.5 plus 6.3. Once again, adding those and stacking them with my decimals. Then I would be multiplying by the 16.5. So 4.5 plus 6.3, decimals lined up. 5 and 3 is 8, and 4 and 6 is 10. I know I'm going to divide 10.8 by 2, and multiply it by the 16.5 as the height. So 10.8 divided by 2, I raise my decimal, and then 2 goes into 10 5 times, which gives me a remainder of 0 for 10 minus 10. And then I bring down my 8, and 2 will go into 8 4 times. So I end up with, I know that I have my length for my bases as 5.4, and it's going to be multiplied by the height of 16.5. So I stack those according to their place value. Multiplying those, I get 4 times 5, which is 20. Put down my 0, carry my 2. 4 times 6 is 24 plus 2. Therefore, I get 26, carry my 2. And then 4 times 1 plus 2, that'd be 4 times 1 is 4 plus 2 is 6. Now I have multi-digits that I'm going to be multiplying, so I underline my next one I'm going to use, circle what's behind it, and that tells me that the second number tells me to bring down 1 0. 5 times 5 is 25. Put down my 5, carry a 2. 5 times 6 is 30 plus 2, 32. Put down my 2, carry my 3. And then 5 times 1 plus 3 is going to give me 8. I add those together. I get 0, 11, carry that 1. And then 6 and 2 and 1 gives me 9, and keep the 8. Once again, multiplying decimals, I count my decimal spaces. There are 2 in the math problem, so I'm going to move it from right to left 2 times. That gives me 89.1. Once again, remembering I'm not going to have a 0 there at the end of my decimal. 89.1 what? Well, in this particular case, I have feet, so I have squared feet. Now, they're going through the steps, telling you the exact same thing, walking you through, and notice that they get the same answer that we do. So we know that our math formula that we're using is indeed correct. So therefore, I want you to try this on your own. Do this math problem, come back and check and see how you did. All right, so hopefully we've got the hang of this by now, and you have your answer, and let's see if you have it set up correctly. So in the formula, we have base A and base B added together. So that's going to be the 3.5 and the 6. And we're going to divide that by 2 and multiply it then by the height of 3. Then we do the math. 3.5 plus 6 is going to be 9.5 divided by 2 times the 3. And 9.5, raising that decimal, 2 goes into 8 4 times, or 2 goes into 9 4 times, which is 8, excuse me. I have 1 left over, bring down my 5. 2 goes into 15 7 times, because 7 times 2 is 14. I have 1 remainder. Well, once again, I have to add my 0 and bring it down, and then 2 goes into 10 5 times. So what I have is 4.75 times the 3, and then I'm going to simply multiply those. 3 times 5 is 15, carry my 1. 3 times 7 is 21 plus 1 is 22, carry my 2. And then 4 times 3 is 12 plus 2, and that's 14. There are 2 decimal positions in my math problem, so we move from right to left 2 times to give us 14.25. Looking at the label, we have feet, so hopefully you put square feet. How'd you do? If you got the right answer, then fantastic, and if you didn't, do you see why? If you can't figure out why, then bring it to me and I'll look at your steps and see where your mistake might be. All right, so when we look at this particular one then, now we're going in reverse. We're going to take our formula, but we're going to have a missing piece. In this case, we're missing the height. So we're going to use the same formula, but then we have to review how we do algebra. So I'm going to plug in that I have 12 plus 15 divided by 2. We know that we have base A and base B added together divided by 2 times the height. Well, I don't know what my height is. So I put multiplied by h, which is my variable, and that's going to be equal to my area of 108. So reviewing algebra, we do the opposite function, then we do it on the opposite side. And here I have to start with, since I'm dividing by 2, I have to get rid of it. The opposite of dividing by 2 is going to be to multiply by 2. So I multiply by 2 on the left-hand side and get rid of it. I go to the opposite side and multiply by 2. 108 multiplied by 2 is 216. So now what I'm left with on the left-hand side where the variable is 12 plus 15 times h. Now I'm going to go ahead and put that 12 and 15 together. 12 and 15 together makes 27. Now I can see that I'm actually multiplying by 27, and therefore I'm going to do the opposite function to get rid of it. The opposite of multiplying by 27 is dividing by 27. I cancel that out. I go to the opposite side. And 216 divided by 27, when I plug in that into my handy dandy calculator, 216 divided by 27, I find that it is a whole number of 8. So what we found is that my height, is indeed equal to 8 feet. Once again, that's going to be a straight unit. It will not be squared because that's a measurement. That's not the area. Does that make sense? Just taking the missing and solving for it using. All right, so let's check out this one that has a missing measurement as well. Still using the same formula that base A plus base B divided by 2 multiplied by my height gives me my area of my trapezoid. I plug in the information that I know into that formula. I know my base A and base B. I have 2 plus 5. That's divided by 2, and I multiply by what I need to find, right? So I keep my variable of h. That's equal to 21, as they tell us that the area is equal to 21. Now, in order to get rid of the division by 2, once again, go back to algebra. I do my opposite function. I then do it on the opposite side. The opposite of dividing by 2 is multiplying by 2, which allows me to cancel them out. Then I do it on the opposite side. I have 21 times 2, and that is 42. That leaves me with 2 plus 5 times the h. I'm going to put my two bases together. So 2 plus 5 gives me 7. So I have 7 times h is equal to 42. And as I've indicated there, to get rid of the multiplying by 7, I have to divide by 7. That's my opposite function to cancel it out. So I go to the opposite side, and I end up with 42 divided by 7. 42 divided by 7, I find out is just an even 6. So my h is equal to 6. 6 what? Well, when I look at my measurement, I have yards for my bases, and I have square yards for my area. I know it has to be a straight label since I'm not finding area, so it has to be 6 yards with the label of yards as well. All right, so we are going to work through one more problem. Now, I chose this one because there's a lot of steps to it. None of them are difficult steps. But it's a lot of math that we have done since the beginning of the year that we need to review. But these are the type of problems that you're going to see on the iLearn as well as going into 7th grade. So we need to know how to do them. If it's a word problem, I like to mark up what's important. I see that I have a budget of $20,000. Wow, that's a lot of money. And I see that it's $8.45 per square foot, which also seems like a lot of money, because per tells me that I have to multiply whatever I get as far as my area by $8.45. It tells me to find the cost to resurface the pool and then see, have they budgeted enough money? Okay, so when I start doing this, I see that I don't just have a trapezoid, right? I'm mixing 8.1 and 8.3 together because I have a parallelogram and a trapezoid. Well, the parallelogram part is not difficult. I'm just going to multiply my base times my height. So I have 32 and 20 that I'll multiply together. And when I'm multiplying by a 0, I know I get 0. So my second number tells me to bring down a 0. And then multiply by my 2, and 2 times 2 is 4, and 2 times 3 is 6. So we're finding that the area of the parallelogram, the top rectangular part, is just 640. Now we do our trapezoid. Now with our trapezoid, we have to use the 32 as well, because that white line, it doesn't tell me anything. But since it is one of the bases of the rectangle, it has to use the measurement of 32. So if I take 78 plus 32 for my base A plus base B divided by 2, and I multiply my height, they tell me that the height in that particular one is 31. 32 plus 78 gives me 110 divided by 2 times the 31, and half of 110 is 55. So I need to multiply those together to figure out what my area is of my trapezoid. So 55 times 31. Multiplying by 1 is just going to give me the same number. So 1 times 55 is 55. My second number tells me to bring down a 0. 3 times 5 is 15. Carry a 1. 3 times 5 is 15 plus 1 is 16. And when I add those together, I get 5, 10, carry the 1, 6 plus 1 is 7, and 1. So the area of the trapezoid is 1,705 square feet, and 640 square feet is going to be added to it for the rectangle. So I find out that my pool, when I do my addition, is 2,345 square feet. Now, once I have that, we go back to the information in the word problem, the word per. I have to multiply that by $8.45. All right, so this we have 3 different numbers we have to multiply it by before we start doing our adding. So I have to multiply by the bottom right by the 5. 5 times 5 is 25. Carry the 2. 5 times 4 is 20 plus 2 is 22. Put down by 2, carry the 2. 5 times 3 is 15 plus 2, that's 17. Carry the 1. And 5 times 2 is 10 plus 1, that's 11. All right, my second number tells me to bring down 1 0. So 4 times 5 is 20, carry a 2. 4 times 4 is 16, plus 2 is going to be 18, carry the 1. 4 times 3 is 12 plus 1, that's 13, carry a 1. 4 times 2 is 8 plus 1, that's 9. Now I have a third number, and my third number tells me to bring down 2 zeros, because there's 2 place values behind it. And I multiply now by my 8. 8 times 5 is 40, put down my 0, carry a 4. 8 times 4 is 32, plus 4 is 36, carry my 3. 8 times 3 is 24, plus 3 is 27, put down my 7, carry a 2. And 8 times 2 is 16, plus 2 is 18. A lot of math. Now we add those together. So in my columns, if I've lined them up nice and neat to where I can see, I have 5, 2, 8 and 7 is 15, so I carry my 1. 6, 3, that's 9, plus 1 and 1, that's 11, carry a 1. 9 and 1 is 10, plus 7 is 17, plus 1, 18, carry a 1. 1 and 8 is 9, and then I have a 1. Counting decimal spaces in my math problem, I have 2 of them, so I move from right to left 2 times. That gives me a mathematical answer of $19,815.25. That's not my answer, though. My answer is yes, right? Because the answer is, did they budget enough to cover the pool? They budgeted $20,000, so the answer is yes. All right, so I went a little bit over my 25-minute goal here, but there was a lot to work on that last one. All right, so on the assignment today, you have 6 questions, once again, through 2 through 12. As you're doing it, please review the video, review the practice problems, make sure you have your notes. If you have questions, though, please ask.